Hello, all my wonderful students. Today I'm not going to be here, as I told you, and I have some more information for you that will help you with the assignment. But before we do that, we will be turning in our assignment that was on solving radical equations. That was on page 425 in your book. So I'd like everybody to get that out. It's page 425, lesson 7-7 in the Algebra 2 textbook I gave you. We will be, this is the way I want to do it. I want you to write down the number of problems you finished that you think you finished correctly. I can't even remember how many problems I gave you for sure, but let's say it was 15 problems. And let's say you finished 12 of them. I would like you to put 12 out of 15. And then I would also like you to list the numbers that you didn't finish. So let's say that I assigned you 21, 23, and 24. I want you to list those as well. And then I want you to put a circle around it. Make sure your name is on it. And I want you to go put your assignment on the flapper board right now. And then Candace, if after they get them on the flapper board, if you'll gather them up and put them in the 2A slot or the 4A slot, depending on which class it is, and put it in on the left-hand side of my boxes over there. And I will go over those tonight. So turn those in. Okay, then I'm going to go over some problems that might help you guys. You'll remember last time I gave you a problem. This is what it looked like. And by the way, in case some of you weren't here, hopefully you watched the video at home of our last lesson. If not, you might want to do that tonight. But we were learning how to solve rational equations. That's what we were doing. Okay, solve rational equations. We only had a chance to go over a couple of examples the other day in class, and so what I'm going to do today is I'm going to go over several more examples. Plus, I'm going to talk more about factoring, which most of you have forgotten from last year. You're actually supposed to learn about it the year before. I reviewed it a little bit last year with you. Factoring trinomials and factoring binomials a second degree as well. But I will review that with you. But I'm going to put this problem up here that we did last time so everybody can get an idea of what a rational function looks like or remember. R plus, I think we had r squared minus 5 over r squared minus 1 equals r squared plus r plus 2 all over r plus 1. And we were supposed to solve this equation. So we started through it. I can't remember if we even finished it. I think we did finish it, but a lot of you didn't understand because I think you don't remember factoring. And so we're going to talk about factoring today because we had to find a least common denominator, LCD, or lowest common denominator, if you want to call it. And the idea of solving a rational equation we found out last time was to find the lowest common denominator or any common denominator, but it's usually easiest to work with the lowest common denominator, and multiply both sides of the equation by the least common denominator, and it eliminates all the denominators. And so we have an equation that has no denominators anymore, no fractions. And then you guys are back to solving equations you know how to solve. So that's the idea. Now, in order to do that, you have to learn how to factor. You have to get all the prime factors of the denominators. Like you're going to have to factor r squared minus 1. R plus 1 is factored already, and so we don't need to factor that. But you need to be able to factor all of these. And if you remember right, last time we talked about r squared minus 1 being a difference of two squares. It factors to be r plus 1 times r minus 1. That's what it factors to be. It's a difference of two squares. And so I'm going to talk about factoring for a second and remind you a little bit about that. So we're going to do a little review right here. So everybody get out, and we're going to your notes, and I want you to do write down a review of factoring quadratics. Now you're going to have to factor more than quadratics to find the lowest common denominator, but this will at least give you an idea. Starting off with, so first of all, we have problems like they're binomials, things like that. That last one I factored on that paper over there. X squared minus 16. Okay, or I'm going to do a couple of them. X squared minus 4. Or let's put 9x squared minus 25. All three of these expressions are what we call a difference of two squares. I think a lot of you guys are probably starting to remember factoring these before, but these are kind of like trinomials. The only difference is the middle term is 0. So we have, I'm sorry, x squared plus 0x minus 16 is what that is. And so really what we're doing is we're looking for what two numbers can we multiply together to get negative 16, so that when we add them together, we get 0. So we want to, what two numbers can we multiply together to get negative 16? Well, in a difference of two squares, this only works when this number right here and this number right here are perfect squares. And also, their difference, that has to be a minus sign in between. And you'll notice right over here, x squared is a perfect square, so is 4, and there's a minus sign in between. 9x squared is a perfect square, so is 25, and there's a minus sign in between. So all these are differences of two squares. Well, we're looking for really, what number can you times by itself and get 16? Well, the answer is 4. But in order to get negative 16, one of them has to be negative 4. So we're going to, so our two numbers that I times together and get negative 16 and add together and get 0 are 4 and negative 4, because we want it to add up to 0. So they have to be opposites. 4 and negative 4 are opposites. And it factors like this: x minus 4 times x plus 4. So that's what it factors to be. So I want you to pause this for a second, Candace, and then all of you students, she's going to give you a few minutes. I want you in your groups, in your pairs, and then your groups of 4, you know, the people in front and behind. I want you guys to figure out these next two problems. Factor them, share, discuss, and we'll come back to this in just a second. So pause it, and then I'll come back to it in a second. Okay, so this is what you should have gotten on this one. Two numbers you can times together and get 4, or 2 and negative 2, and add together and get 0. So this factors to be x minus 2 and x plus 2. By the way, it doesn't matter whether the factor with the minus signs first or last, so it could have been x plus 2 times x minus 2. And then this one over here, the square root of 3x squared is 3x. So 3x square root of 25 is 5, so 3x minus 5 times 3x plus 5. And that's a difference of two squares. So look for those when you're doing this assignment, because you're going to have a few of them. Okay, so difference of two squares. So that's a review of factoring quadratics of when it's a difference of two squares. Now, the other type of problem is factoring trinomials. Trinomial quadratics. Remember, what makes it quadratic is the x squared. So let's say I had something like x squared plus, let's say 7x plus 12. Okay, we all remember how to do this. I have to find the two numbers. When the coefficient of x squared is 1, as it is right here, it's 1x squared, then I'm looking for the two numbers I can multiply together and get 12, so that when I add them, I get 7. So I'm looking for those two numbers. I'm going to put them in two binomials. First of all, I know that x times x is x squared, so x and x are going to go there. So the two numbers I can get times together and get 12, and add together and get 7. I think most of you probably figured that out by now. That's 3 and 4. Because 3 times 4 is 12. 3 plus 4 is 7. And I've factored it. Okay, let's do another one. Let's say I have x squared minus 5x. Let's say minus, let's go 36. Looking for the two numbers I can multiply together, so they multiply together, they make negative 36, and when I add them together, they equal negative 5. So pause this for a second, Candace, while everybody has a chance to work in their groups to find this out. Okay. Well, once again, x times x is going to make x squared. So I know the x's go there. I have several choices of numbers that are going to multiply together and get negative 36, but one has to be positive, one has to be negative. I know that, for instance, 1 times negative 36 works, and so does negative 1 times 36. I know that 2 times negative 18 works, and negative 2 times 18. I also know that 3 times negative 12 and negative 3 times 12 work. I know that a negative 4 times 9 and 4 times negative 9 work. And I also know that 6 times negative 6 will make negative 36. Okay, so I got a lot of choices, but I'm looking for the ones that when you add them together, you get negative 5. Well, that means the difference between them has to be 5. Well, I know that negative 4 plus 9 would make a positive 5. Negative 4 minus 9, or plus a negative 9, would make negative 5. So my answer is this one right here, 4 and negative 9. And it doesn't really matter which one goes where, but x plus 4 times x minus 9 would give me the correct answer. So that's factoring trinomials. I can't remember. Let me check to see if we have trinomials. I think that covers it for the factoring. Okay, you're going to also maybe have to factor out a greatest common factor. For instance, if you had something like 4x squared y plus 2xy to the third, greatest common factor, what's the biggest number that goes into 4 and 2? Well, it's 2. What's the biggest number that goes into x squared and x? Well, it's x. Well, hold on. It's x. And what's the greatest number that goes into y and y cubed? It's y. So I'm going to factor out a 2xy out of each term. Well, basically, if I divide 2xy into each of these terms, whatever I have left will go right here between, and with the plus sign in between. So 2 will go into 4 twice. We divide x into x squared, we get x. Divide y into y, we get 1. So it's just 2x after we factor out a 2xy in that first term. In the second term, if I factor out a 2, I get 1. Factor out an x, I get 1, but we don't need to put another 1 there. If I factor out a y, I'm left with y squared. So my answer is 2xy times the quantity 2x plus y squared. So factoring out a greatest common factor. So hopefully that helps in your factoring. Now, back to this problem right here. we have to factor, find the greatest or the least common denominator of all the terms of this equation. Well, I have three terms. I have this one here. So I'm going to box them in. I have that term there. I have that term there. They're separated by plus and minus signs, like that's a plus sign and equal signs. And I have this term right here. And as I explained the other day, I can't just go ahead and cancel out r squared divided by r squared. I can't do that because like in the r squared minus 5 over r squared minus 1, that is one whole factor together. And you can't, because it messed up order of operation. Order of operation says I have to do grouping symbols first. Well, this divide sign makes a grouping symbol. And so I can't just divide r squared by r squared here. If it was r squared times, if it was 5 times r squared and negative 1 times r squared, then I could cancel them out. But you have a minus sign there that doesn't allow that. So what we're going to do, we already factored that, but I'm going to write it down here. We got to find the least common denominator first. Well, you know, right here we have r over 1. So we have a denominator of 1, so we have a factor of 1. Right here, that factors to be, the r squared minus 1 factors to be r minus 1 times r plus 1. So we have two factors there, r minus 1 and r plus 1. And then over here, this one's already factored, and so I just have an r plus 1. Well, the least common denominator is found by taking every factor that occurs, the most number of times it occurs in each term. So I know that 1 occurs, but 1 isn't going to change anything because 1 divided anything is just itself. So r divided by 1 is just r. So that one's not going to help us out. But r minus 1 occurs here, and r plus 1 occurs here. And since we've already counted r plus 1, we don't need the one over here. So our common denominator is r minus 1 times r plus 1. So we're going to write r minus 1 times r plus 1. That's our least common denominator. Okay, so I took every factor that occurred, the most number of times it occurred in one term. So even though r plus 1 happened here, right here, and right here, it only occurred once in each of those terms. And so we can't take it more than that. Now, if it happened r plus 1 times r plus 1, then I'd have to take two r plus 1s, but it didn't happen that way. I'm going to erase this. And we are going to do this problem right here by writing out the least common denominator over here, r minus 1 times r plus 1, and timesing it by each term. So we're going to times it by r. So we're going to start off by writing the least common denominator, r minus 1 times r plus 1 times r. Okay? And think of timesing both sides by the least common denominator. So I have to distribute it. I have to times it by the r, and the r squared minus 5 over r squared minus 1. So that's what we're going to do next. We're going to take and multiply the least common denominator by r minus 1 times r plus 1 times the term r squared minus 5 over r squared minus 1. Now remember, r squared minus 1 is r minus 1 times r plus 1. Equals, and then I have this whole thing over on this side. I have r minus 1. I'm going to have to write a little small. Times r plus 1 times r squared plus r plus 2 all over r plus 1. Okay, what happens here is in this first term right here, nothing cancels out because there's no denominator and numerator. But over in the second term, this r minus 1 cancels with this r minus 1, and this r plus 1 cancels with this r plus 1. And so I'm going to rewrite this left side of the equation right now. Well, let's cancel everything. And over here, the r plus 1 cancels with this r plus 1. So I have no more denominator. So the problem's going to look like this now. R minus 1 times r plus 1 times r plus the r squared minus 5 equals the r minus 1 times the r squared plus r plus 2. That is that problem. Now, no more denominators, but that looks kind of like a scary problem to some of you. But what we're going to do is simplify it down. We've got to use the distributive property first. So we're going to start off by timesing r times r times 1, negative 1 times r, and negative 1 times 1. Well, the middle terms you're going to find out because we're going to get r squared plus r minus 1 times by this r right here. And you'll notice that in the middle, r minus r is 0. So I'm going to end up with r squared minus 1 times r. And then I have the plus r squared minus 5 from above equals, and I'm going to move this up for everybody, equals, on this other side, I'm going to have to distribute. R times r squared is r cubed. R times r is r squared. And r times 2 is 2r. Then I've got to distribute the negative 1. Negative 1 times r squared is a negative r squared. Negative 1 times r is negative r. And negative 1 times 2 is negative 2. So, going back over here, I've got to come back to the left side again. I've got to distribute the r through here. So I've got to times this r by both terms, that one and this one. So I'm going to get r cubed minus r plus r squared minus 5 equals, and then on the right side, I'm going to combine like terms right now. R cubed, there's an r squared minus an r squared, which makes 0r squared, which we won't write. There's a 2r minus r, which would be make a plus r, and then we have a minus 2. Is that right? Okay, then, if I haven't made a mistake, hopefully I haven't, let me just look back over it a second. Okay, I think I've done it right. So what we're going to do now is we're going to gather everything to the right side. And you'll notice, first of all, if I minus an r cubed from both sides, those are going to add up to 0. I'm also going to minus an r, and I'm going to add a 2. The reason I do this is because after I add up the r cubes, they're going to add up to 0. And I'm going to put this term right down here first. That's my r squared term. I'm going to put it in descending order. So r squared. And then I add negative r and negative r make negative 2r. And negative 5 plus 2 is negative 3. And then on my right side, I have equals 0. And I have a pretty simple quadratic equation. Now last year, we spent a little bit of time solving quadratic equations. In order to solve a quadratic equation, first of all, you have to set it equal to 0 like I did. Then you have to factor the trinomial if it will factor. If not, you can use a quadratic formula or completing the square. But this one, however, does factor. I'm looking for the two numbers, just like we practiced a little bit ago, that when you multiply together, you get that negative 3, and when you add together, you get that negative 2. So I know that negative 3 times a positive 1 is negative 3, and when you add negative 3 and positive 1, you get negative 2. So this factors to be r minus 3 times r plus 1 equals 0. You set each factor equal to 0, and add 3 to get r equals 3, minus 1 to get negative 1. And those are my two solutions. Now, I probably need to check that to see, not probably, I need to check it to see if I have any extraneous solutions. Just like radicals, rational equations have extraneous solutions. So I am going to take 3 and negative 1, and I'm going to go back up to my original problem. 3 and negative 1, and I am going to plug in 3 first of all, and I'm going to find a color that I haven't used too much of. I'm going to put it in above. If I put 3 in, I get 3 right there, plus, and I'm going to do a little bit of this in my head. If I put 3 in right here, I'm going to get 3 squared is 9, minus 5 is, 9 minus 5 is 4. And on the bottom, I'm going to get 3 squared is 9, minus 1 is 8. So I'm going to get 4 over 8, which is 1/2. So if I add those together, I get 3 and 1/2 on the left side. Equals, let's see if I did that right. 3 squared is 9, minus 5 is 4. 3 squared is 9, minus 1 is 8, so 1/2, yeah. Okay, so on the right side, I have 3 squared is 9, plus 3, plus 2. That's going to be 14. And then I have 3 plus 1 is 4, so 14 divided by 4. Well, 4 will go into 14 3 and 1/2 times. So we do have 3 and 1/2 equals 3 and 1/2. Therefore, that number 3 works. So now I've got to try -1. So I'm going to, that was my other solution. So I'm going to erase these right here. And I am going to put in -1, so that's going to make that -1. -1 squared is a +1 minus 5. So 1 minus 5 is a -4, so I have -4 on top here. And then -1 squared is +1 minus 1. I'm going to get 1 minus 1 right here, which is 0. And notice that that 0 is in the denominator. Some of you guys probably figured out that you can't divide by 0, and so that's undefined. And I have an undefined problem right here, and so -1 is not a solution because it makes the denominator 0. And in fact, it would make the denominator over here 0 as well. If I put -1 plus 1, that would make that 0. So we go back down. My only true solution is 3 right here. Whoops, 3 right here. R equals 3. That's my only solution. This one right here is extraneous. So that's how you do that problem. Now, I know that's overwhelming to some of you, but we're going to practice some of these. What I want you to do right now, I'm going to give you a problem to practice. I want everybody in your groups, we're going to try a problem sort of like this one. So here it goes. Got to get my book where I can see it, my glasses so I can see. We're going to go to a new slide here, and we're going to do this problem right here, 7n over 3n plus 3. 7n over 3n plus 3. Minus 5 over 4n minus 4. Minus 5 over 4n minus 4. Equals 3n over 3n plus 2. 3n over 3n plus 2. And that is the problem that we are going to do. So I'm going to have everybody, and we're going to pause this, and I want everybody to, in your pairs and then in your groups, I want you to see if you can figure this out. Remember, you got to completely factor the denominators and find the least common denominator that you can times by both sides. So we'll pause it here. Since you had time to work on this one in groups already, I don't want to take a lot of time on it, so I'm just going to do it kind of quickly. You can check your work to see if you got it right. But if I factor a 3 out of 3n plus 3, I'll get 3 times n plus 1. If I factor a 4 out of 4n minus 4, I get 4 times n minus 1. And then over here, 3n plus 2 is not factorable, so we can write down 3n plus 2 as the factor. Okay, so because it's completely factored. And so I need to take every factor that occurs, the least number of, or the most number of times it occurs in each thing. Well, guess what? Every single factor in here is, every factor in here is only mentioned once. And so my least common denominator right here this is my least common denominator, or lowest common denominator, however you want to say it, is going to be all these factors. It's going to be 3 times 4, which is 12, times n plus 1, times n minus 1, times 3n plus 2. Now, we're not going to multiply those all together right now, because in each factor, when we multiply it by each factor up here, these are all, different ones are going to cancel out. And so, so I'm going to kind of write it above right up here. If I was to multiply this least common denominator by this 7n over 3n plus 3, the first term, the 3n plus 3's, well, the 3 and the n plus 1, because that's what this comes out to be, is they're going to disappear. They're going to cancel out. And so, you know, if you wanted to rewrite this 12 as 3 times 4, it might help you as you're doing this. So the 3 times n plus 1 is going to cancel out on this first one, and that's going to leave me with it's going to leave me with a 4 times an n minus 1 times a 3n plus 2. And then on this 5 over 4n minus 4, the 4 times n minus 1 is going to cancel out. So the 4 and then n minus 1 is going to cancel out. So it's going to leave me with 3 times n plus 1 times 3n plus 2. I'm going to times by that 5. And then the last one on the right side of the equal sign, the 3n plus 2 is going to cancel out. So that's going to leave me with 3 times 4 is 12 times n plus 1 times n minus 1. Okay, now I know these are kind of long problems, but these are the kind that they have examples of that you guys have to know how to solve on the core curriculum. So we have to multiply, up here we've got to multiply 7n by what's left of the common denominator. So I first of all will know that 7 times 4 is 28. So I'm going to have a 28n times a n minus 1 times a 3n plus 2. And these all canceled out, remember, when we multiplied them. So those are all gone. And then I'm going to have a minus sign, and I'm going to have a 5 times 3, it's 15, times the n plus 1 times 3n plus 2 that was left over. If you're not seeing where all this is coming from, ask somebody. You can pause it, Candace, if we need to. Okay? And then the last one, 3n times 12 is 36n times n plus 1 times n minus 1. Okay, so we have this problem. We have no more denominators because they all canceled out when we multiplied the least common denominator by them. So I just got to multiply all those out, get them all on one side, and solve it. Well, I'm going to, first of all, on this one, I'm going to times all the binomials together. So right here, I'm going to have a 28n times n times 3n is 3n squared. N times 2 is 2n. Negative 1 times 3n is negative 3n. And negative 1 times 2 is negative 2. And over here I have minus 15 times n times 3n is 3n squared. N times 2 is 2n. And then 1 times 3n is 3n. And 1 times 2 is 2. And I have, over here I have 36n times n squared minus 1. I know that that's a difference of 2 squares, n plus 1 and n minus 1, so it's going to make n squared minus 1. Okay, then I distribute the, well, I've got these two terms right here add up to negative n, so so we just know that's negative n. So down here I have, when I distribute the 28n, I'm going to have 3 times 28. That is going to be, I believe, 84. 28 times 3 is 84. N times n squared is n cubed. And 28n times a negative n is going to be a negative 28n squared. And 28n times negative 2 is going to be a negative 56n. Over here, minus, now I'm going to distribute this negative 15 over here. And I know that these two middle terms, 2n and 3n, add up to 5n, so I'm just going to, when I get to that one, I'll do that. So 15 times 3 is 45, n squared. 15 times 5n is negative 75n. And 15 times 2, negative 15 times 2 is a negative 30. And then equals 36n times n squared is 36n cubed minus 36n. For some reason, I'm starting to wonder if I did something wrong. Because the n cubes aren't going to cancel out. I'm not sure if that was meant or not, but we'll continue the problem, see what happens right here. So we have, we're going to get everything on one side. So if I minus, I have a 36n, should be 36n cubed over here on the right side. So if I minus a 36n cubed and add a 36n to both sides, that means minus 36n cubed, and add 36n. Then I'm going to get 48n cubed minus 20, well, 28 and 45, so 73 minus 73 n squared let's see, that's negative 56n plus 36n is negative 20n, minus 75n is negative 95n, equals 0. Okay, and then since we don't have a constant term, every term has at least an n in it. And so we can factor out at least an n out of each one of these, and we may be able to factor out more. Well, I know it looks like I can only factor out an n, so I'm going to have factor out an n. I'm going to get 48n squared minus 73n minus 95 equals 0. If I divide both sides by n, those cancel out on this side, so I get 48n squared minus 73n minus 95 is equal to 0 divided by n is 0. So now I've got it down to a quadratic equation. I can use the quadratic formula to solve that. I'm thinking that's a pretty darn big number, and because it's a pretty big number, I'm going to have to stop this and see if that's right or if I made a mistake up there adding or multiplying somewhere. So I will pause it for a second and then I'll come back to it. All right, class. I just figured out why this problem isn't working out. I wrote it down wrong. Right up here was supposed to be a 2n plus 2, which made all the difference in the world. I was wondering why this was turning into such a long problem. I will tell Candace not to have you do this one as an example. Hopefully she can skip that one. I'll try and figure out where it is in the presentation and have her skip it. Okay, but we'll move on to the next one. In fact, what I'll do is I'll rewrite that problem down and we'll do it. But this time, hopefully we'll get it right. 7n over 3n plus 3 equals, or minus 5 over 4n minus 4. Minus 5 over 4n minus 4 equals 3n over 2n plus 2. 3n over 2n plus 2. Okay, now I want you guys to take a few minutes, see if you can figure it out in your groups. Candace will pause it, and then we'll come back and do it together. Okay, so we're going to find the least common denominator, which if we factor 3 times 3 out of this first factor, it's 3 times n plus 1, or the first denominator. 4 out of this one, it's 4 times n minus 1, and this one, it's 2 times n plus 1. So I take every denominator that occurs, the most number of times it occurs in each factor. So there's a 3, there's a 4, and there's a 2. There's also an n plus 1. Even though it happens in 2 different terms, we only list it once. An n minus 1. That's our common denominator. 3 times 4 times 2 times n plus 1 times n minus 1. Okay, I will take now and I will times this common denominator. And you can think of 3 times 4 is 12, times 2 is 24, so you can think of this as 24. So we're going to times 24 times n plus 1 times n minus 1 by each of these. 24 times n plus 1 times n minus 1, and 24 times n plus 1 times n minus 1. Okay, well, I know that this factor right here, we factor into 3 times n plus 1. 3 will go into 24 8 times, and the n plus 1's cancel out. So I'm going to be left with 8 times 7 is 56 times n minus 1 in this one. Okay, I go to the next one. I know that the 4 will go into 24 6 times, so that factors into 6, and the n minus 1's will cancel out. So n minus 1's will cancel out, so I'm left with 6 times 5 is 30 times n minus 1. And the last one, I know that 2 will go into 24 12 times, and the n plus 1's cancel out. So I have 3n times, well, I have 3n times 12, which is 36n, times n minus 1. Okay, now, so I distribute each one of these. So 56n times n is 56n squared minus 56n. Over here, negative 30 times n is negative 30n. Negative 30 times negative 1 is, okay, I was looking back up top. Negative 30 times negative 1 is positive 30. And then 36 times n is 36n squared, and 36n times a negative 1 is negative 36n, just 36n, not squared. Okay, so I get everything on the left side, so I'm going to minus the 36n squared and minus the 36n from both sides. So minus the 36n squared and add a 36n, I should say. I'm kind of in a hurry. Add a 36n. And I am going to get 20n squared. And negative 56n plus 36 is a negative 20n. Minus 30n would be a negative 50n. Plus 30 equals 0. This is kind of nice because 10 will go into all of those. So I can factor out a 10. That's going to leave me with 2n squared minus 5n plus 3 equals 0. Divide 10 into both sides, and the 10's will cancel out on this side. Be 0 on the other side. So it comes down to factoring this. This will factor. Okay, I know that I'm going to have a negative 3 and a negative 1. Negative 1 times negative 3 is a positive 3, which will get me that one over there. But I didn't go any of these factoring, but I know that 1 times 2 is 2. So I know one's got to be 1n squared, and one's got to be, 1n, and the other one's got to be 2n. I know that the 2n's going to go over here, and I'll show you that in a second. The reason being is if we multiply these back together my two middle terms. N times negative 1 is negative n, and negative 3 times 2n is negative 6n. When I add them together, I get a negative 5n for the middle. So I know that's right. So then I said each factor equal to 0. I solve each one of those, and I get two solutions. I minus 1, or add 1, divide by 2, I get n equals 1/2. You can check those solutions. You should find out that they do work. So they will work. So those are my two solutions. Sorry, I meant to pause that while I did that. But what I'm going to do is, I wrote it down for you last time. I think most of you got it down. It's 10 through 17 all. And then you're going to do problems 24, 25, and 33. That's your assignment. So you can have the rest of the class period to work on this. Good luck with it. Work hard on it. Watch the video again if you need to understand it. Try to get as much of it done as you can. If we have a few questions, we'll answer those next time. Okay, good luck. Bye.